Today's class, we are looking at topic 2 in our unit, Matter and Chemical Change. So we're looking at changes in matter today. So firstly, we'll talk about a physical change. A physical change, that means a substance changes in form, but not in its chemical composition. For example, water, it can be frozen to ice, or it can be water vapor, but it's still H2O. It doesn't change its chemical composition. As well, there's no new substance being formed. It's still H2O. And these new properties, they're temporary because a change of state can be reversed. So the example here, liquid water can easily be converted back into solid ice again. So just examples of some physical changes, crushing a can, melting an ice cube, boiling water, mixing sand with water. You can still easily separate the two. Breaking glass, dissolving sugar in water, you can still separate the two. Shredding paper, chopping wood, just mixing some marbles, green and red marbles together, sublimation of dry ice. These are all physical changes. Okay, it alters the appearance of the matter, but not its chemical composition. A chemical change, on the other hand, causes one or more new substances to be formed, and it's difficult or impossible to reverse. So for example, burning paper, this would be a chemical change. There's smoke that escapes, there's ashes that are left behind. You can't combine those together again to form the original paper. So the change cannot be reversed. Okay, so that's how we know it's a chemical change. Another example will be cooking. For example, cooking an egg. The proteins have changed. You can't reverse cooking an egg. You can't get the egg how it was before you cooked it. So therefore, it's a chemical change. And also, you've applied heat to it. So these are some examples of chemical changes. Rusting, iron rusting, that's a chemical change. Any type of burning, burning wood, that would be a chemical change. Metabolism, and as we digest our food, there are enzymes involved in our stomach. You may remember that from grade 8 when we looked at the digestive system. That is a chemical change. Cooking, baking, those are chemical changes. These are some other examples. Electroplating, rotting banana, that's a chemical change. A vinegar and baking soda mixture, there's a chemical reaction taking place there, and we have something new being formed, a new substance is being formed. Therefore, it's a chemical change. Fireworks, chemical change. This is a chemical battery, which also demonstrates chemical change. So how can you be sure about changes? So usually if you can make 2 or more of the following observations, then you know a chemical change has probably taken place. So for example, heat is being produced or absorbed, the starting material gets used up, there's a change in color, a material that has new properties is formed, gas bubbles form in a liquid, a precipitate forms in a liquid. The change is difficult to reverse. When I talk about a precipitate forms in a liquid, that's when a solid is being formed. So if you take 2 liquids, mix them together, and a solid forms at the bottom of the beaker, that's what I mean by a precipitate forms. And to be certain that a new substance has formed, tests are usually done before and after the change. All right, so next we're going to talk about properties of matter. So when we talk about properties of matter, they're either physical properties or there's chemical properties. When we talk about physical properties, these can be observed or measured without changing the identity of the substance. So for example, looking at its appearance, its texture, the color, the odor, its melting point, boiling point, density, and solubility, those are all physical properties. Chemical properties, these can be observed or measured as a substance changes in identity. So examples of chemical properties would be its ability to burn or its reactivity. All right, so continuing with properties, chemical or physical. So a physical property, it's any property that can be observed or measured without forming a new substance. All right, so examples here, a phase, for example, mercury is a liquid. That's its phase at room temperature. Color, if you've ever seen sulfur, sulfur is yellow. The odor, for example, hydrogen sulfide, it smells like rotten eggs. Conductivity, if it can conduct electricity, for example, copper is a good conductor. Melting point, we know ice melts at 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. Solubility, for example, salt, it can dissolve in water. Magnetism, iron is attracted to a magnet. Aluminum, on the other hand, is not. Density, for example, oil is less dense than water. If you mixed oil and water and let it settle, eventually you'd see the oil on top of the water would be on the bottom, and that has to do with density. So all of these are physical properties. So physical properties can be measured qualitatively or quantitatively. So when I talk about qualitative physical property, it's a characteristic of a substance that can be described, but not necessarily measured. So it's a quality. So for example, on the left side here, qualitative physical properties like physical state, color, odor, crystal shape, malleability, ductility, hardness, brittleness, those are qualitative physical properties. Quantitative physical properties, these can be measured numerically. It's a quantity. So for example, the melting point, boiling point, it's measurable. Density, solubility, electrical conductivity, thermal conductivity, those can all be numerically measured, so they're called quantitative physical properties. All right, so make sure you know the difference between those two. Just continuing with physical properties, I talked about malleability and ductility. So those just mean if something is malleable, it can be hammered into shapes or bent without breaking, and if something is ductile, it can be drawn into wires. So that's what those two words mean. And then lastly, we're going to talk about what's chemical property. So a chemical property, it's any property that describes how a substance reacts with another substance, and it's forming a new substance. So for example, combustibility, this is the ability of a substance to burn in oxygen. So oxygen is required for combustion. And combustion creates new substances, for example, smoke and ash. So therefore, it is a chemical property. Example, hydrogen burns in oxygen, so it has the property of combustibility. Helium, on the other hand, does not burn in oxygen, so it does not have the property of combustibility. And this brings me to, if you remember the blimp, Hindenburg, I believe it was called. It was filled with hydrogen gas and it burned. There was a spark or something which caused it to burn, and many people died that were traveling in that blimp. Whereas helium, if you fill up the blimp with helium, there's not that danger of helium gas burning. All right, so just some chemical properties and some examples. Flammability, so for example, gasoline burns. Acidity, hydrochloric acid is an example of acidity. Reactivity with water, sodium burns in water. Reactivity with air, iron rusts. So for example, we were talking about vehicles and how they can start to rust. Reactivity with acid, limestone bubbles when they're placed. Limestone will bubble when it's placed in acid. All right, so just some more chemical properties and chemical changes. So here, zinc reacts with acid, sulfur will burn in air. Here we have some rusting of iron. Chemical changes, so before we have or wood log. So during burning, so log is getting burned, and then after we have this new substance, this pile of ash and smoke, which is not shown there. Okay, so I'm going to pause here. We'll watch a couple of these videos here on chemical changes versus physical changes and properties.